Now we are going to do the first experiment with LPC2148. The first experiment will be blinking of some LEDs connected to GPIO port. So here I have connected 16 LEDs from P1.16 pin number P1.16, that is 16th pin of port 1 till 31st pin of port 1 P1.31. So 16 pins I have connected from P1.16 to P1.31 through 100 ohm resistance. So you are going to write a program for blinking of these 16 LEDs connected to port 1. So these are the steps for blinking of these LEDs. So first step, what will be the first step? In the previous slide I have told that each pin is having multiple functionality. So in this case I need to configure P1.16 to P1.31. These 16 pins I need to configure the functionality as GPIO port, because these pins can be configured as a ADC or timer or external interrupt, etc. In my experiment I need to configure P1.16 to 31 as GPIO port pin, right? So that is the first step. Second step, I need to configure the direction of these pins P1.16 to 31. So whatever GPIO port you are taking, you need to configure two main things. First one is known as the direction, second one is known as the data. So why you need to configure the direction of a GPIO pin? Say in my example you are going to connect an LED to P1.16 to P1.31. So what should be the direction of those pins? Those pins should be configured as output pins or output port pins. That means the direction of those pins should be output. Why? Because LED is an output device. So if you want to make the LED on, you need to generate a current signal or a voltage signal from the pin to the external world. So if you want to generate a signal in a pin, that pin should be configured as output port pin, or the direction of that pin should be output. So since I am connecting the LED or output device in my experiment, those pins, pin number P1.16 to 31 should be configured as output pin. Similarly, if you are going to connect a switch to that pin, that pin should be configured as input pin. Why? Because the switch is an input device. So when you are pressing a switch, you are giving a signal from the external world to the microcontroller. So in that case, that GPIO port pin should be configured as input, right? So you need to configure a pin as input or as output depending upon the device which you are connecting. In my case, I am connecting an LED, so it should be configured as output pin. If you are connecting an switch, it should be configured as input pin. So the first main parameter you need to configure in a GPIO configuration is direction of that port pin, right? Second parameter you need to configure is that you need to configure the data of those pins. So data means what? Say in my case you are connecting an LED, so you are configuring the direction as output. Then I need to make the LED on. How will you make the LED on? In that pin you need to write a logic high signal. So logic high means VCC or the supply voltage of this controller will be generated in that pin. Here LPC, all the ARM based microcontrollers VCC is 3.3 volt. You need to keep it in mind. Most of the other microcontrollers like Arduino, Atmel, etc., they are PIC, etc., they are operating on 5 volt VCC, but ARM based microcontrollers will be operating on 3.3 volt VCC, right? So if you want to make the LED on, you need to generate a VCC of 3.3 volt or in that pin. So if you want to generate a 3.3 volt VCC there, in digital you need to write a logic 1 there or logic high there. Similarly, if you want to make the LED off, you need to write a digital 0 or logic low there in that pin. When you are writing logic low or 0 in that pin, because each pin you can write either 0 or 1 as data. So if you are writing a logic 1 or data as logic high, that pin will be generating VCC. If you are writing a logic low to that pin or logic 0 to that pin will be generating ground or the ground or 0. Right. So if you want to make an LED on, you need to write a logic 1 to that pin. If you want to make that LED off, you need to write logic 0 to that pin. That means you are writing 1 or 0 as data to that pin. In the previous step, you are configuring the direction of that pin. In the next step, if you want to make the LED on, you need to write a logic 0 as data. Right. So you are configuring two parameters. One parameter is known as the direction, another parameter is known as the data. These are the two parameters. And how will you configure the direction and data? We'll see. So these are the main steps used for blinking of an LED. First step is you need to configure the functionality of those pins as GPIO port pin. Second step is you need to configure the direction of those pins as output port pin or output direction, because you are connecting an output. LED is an output device, you are connecting that. Next step is that you need to write a logic 1 as data to that pin, so the pin will be generating VCC and LED will be on. Similarly, if you want to make the LED off, you need to write a logic 0 to that pin, so LED will be off. So these are the four steps. So we will see the first step. You need to configure the functionality of P1.16 to 31 as GPIO. So next, you need to see how to configure the functionality of those pins. So for configuring the functionality of a GPIO pin, you are using a register known as a special function register known as pin select register, pin cell register. Previously, we have seen a register known as VPB divider. It was used for configuring the P clock from CCLK, C clock. Similarly, for configuring a GPIO, you are having a set of special function registers or SFRs. First set of register is known as pin cell register. These registers are used for configuring the functionality of each pin, because each pin is having more than one functionality. In my case, I need to configure the functionality of P1.16 to 31 as, that is port 1.16 to 31 as GPIO port, right? Not in any other functionality. So I told there are pin select registers used for configuring the functionality. And here there are, in this controller, there are three pin select registers: pin cell register 0, pin cell 0, pin cell 1, pin cell 2. Pin cell 0 register is used for configuring the functionality of pins from P0.0 to P0.15. Right? Pin cell 0 is used for configuring functionalities of pins from P0.0 to P0.15. Similarly, pin cell 1 is used for configuring functionalities of pins from P0 point, that is port 0, 16 to 31. Pin cell 1 is used for configuring functionalities of P0.16 to P0.31. And the last pin select register, pin cell 2 register, is used for configuring functionalities from P1.16 to P1.31. Right. So pin cell 2 register is used for configuring port 1 16 to 31. Pin cell 1 is used for configuring port 0 16 to 31. In my case, I have connected LEDs to port 1.16 to 31. So I will be using pin cell 2 for my configuration of the functionality of port 1. So this is the pin cell 2 register description. So register description shows what are the functionalities of each pin. When you are configuring a particular bit, not pin, bit. If you are configuring a particular bit of this SFR, what will happen? So here you can see that if you are configuring the second bit of pin cell 2 register with a value 0, That means if you are writing 0 value to second bit of this register, you can configure P1.26 to 36. So this is applicable for the other versions of LPC21 series. So in your 2148 you are having pins from P1 point, you are having pins only up to P1.31. You need to keep in mind. So P1.36 will be available in another 214 series. So in our case you are having only up to P1.31. So in my case you can consider, in our case you can consider it as P1.31 to 26. If you want to configure these pins as GPIO, you need to configure or you need to write this bit value as 0. Similarly, if you are writing this bit number 2 value as 1, you will be configuring the same pins 16 to 31 as debug port pins. So in my case, I need to configure P1.26 to 31 as GPIO. So what value should I write? I should write 0 in bit number 2 of pin cell 2. Similarly, I need to configure bit P1.16 to 25 also as GPIO. So what value should I write? I need to write a value 0 in bit number 3. Right. So if I am writing value 0 in bit number 2 of pin select 2 register and value 0 in bit number 3 of pin select 2 register, you will be configuring P1.16 to P1.31 as GPIO. Right. So what value should I write? I need to write a bit value 0 in bit number 2, value 0 in bit number 3. So total pin select 2 register is a 32-bit register. In that only 2 bits you are configuring. Right. So if you are taking hexadecimal equivalent of 32 bits, it will be this bit 0, this bit 0. So hexadecimal equivalent will be 0. So if you are writing pin select 2 equal to 0, that means all bits 0, you will be configuring P1.16 to P1.31 as GPIO pins. Right. So if you are writing a value 0 to pin cell 2 register, you will be configuring P1.16 to P1.31 as GPIO. So here 0 means it is actually 32 zeros. You are configuring only 2 bits. So here 0 means it is hexadecimal 0 or decimal 0. That means actually 32 bits will be there. All the 32 bits you are configuring it as 0. That is meant by the 0 actually. So by writing pin cell 2 equals 0, you are configuring the functionality as GPIO. What is the second step? You need to configure the direction of these pins as output. Right? Why? Because you are going to connect LED. LED is an output device. So you need to generate a voltage or a signal from the microcontroller to the LED in order to make it on or off. In that case, that pin should be configured as output. So whenever you are configuring an output device, you need to configure that pin direction as output. So here I am going to configure the direction of P1.16 to 31 as output. So how will I configure that? So for configuring the direction of a GPIO port, you are using a register known as IODIR X register. IODIR X. That X stands for the port number. Right. In my case, I need to configure port 1 16 to 31 pins as output. So I need to take a register known as IODIR1 register. This is O, it is not 0. So IO direction register. So IO direction register is used for configuring the direction of a port. 1 means you are configuring the direction of port 1. Right. Again, as I told before, IO direction register is also a special function register. So that also will be having 32 bits. Right. And each bit of IO direction register is having a one-to-one mapping with corresponding pins. So bit 0 of IO direction 1 register is used for configuring P1.0th pin, 0th pin of port 1. Similarly, bit 1 of IO direction 1 register is used for configuring P1.1 pin. Similarly, bit 31 of IO direction 1 register is used for configuring P1.31 pin. So these are the pins which are having one-to-one mapping with the IO direction register, right? So by configuring bit 0 of IO direction register, you can configure the direction of 0th pin of port 1, 0th pin. Similarly, by configuring bit 31 of IO direction 1 register, you can configure the direction of P1.31, that is 31st pin of port 1, right? And here you need to keep something in mind. In LPC2148, you are having only pins from P1.16 to 31. So you need to configure only these bits. The other bits will be don't cares for you, right? P1.16 to 31 only you need to configure. So you need to find out what value should be written to bit 0 to bit 31 or corresponding bit. What value, if you are what is the value that is to be written here in order to configure this pin as output or input in the case of direction. So this is a direction register description. So you can see that if you are writing 0 in a particular bit, that pin, corresponding pin will be configured as input. Similarly, if you are writing a value 1 in a particular bit, that corresponding pin will be configured as output, right? So if you are writing 1 here in bit 0, what does it mean? P1.0 will be configured as output. If you are writing 0 here in bit 1, what does it mean? You are configuring P1.1 as input. In my case, I am using 16 LEDs connected to P1.16 to 31. So all the bits from P1.16 to 31 should be written with what value? 1. So 1, 1, 1, 1, 1. Each bit should be written with 1 value. So when you are writing 1, you are configuring that corresponding pin. If you are writing 1 here, you are configuring P1.16. That corresponding pin, you are configuring it as output. So when I am writing 1, you are configuring this as output. Similarly, all the other bits from 16 to 31 should be configured as output. Why? Because you are connecting 16 LEDs. So direction of port 1 you can configure, all the port pins direction you can configure it separately, and all the other pins bits value can be either 0 or 1, it is don't care. So for time being I am writing all these 32 bits as ones. So what will be the hexadecimal equivalent if you are writing 1 1 1 1? What does it mean? 1 1 1 1 in hexadecimal, what will be the hexadecimal equivalent of 1111? It will be F. So similarly, 32 ones, if you are writing the hexadecimal equivalent, it will be 0x FFFF. 1F represents 1111, 4 bits. 0x shows that this representation is hexadecimal representation 0x. 0b, if you are writing 0b some value, it shows that bits are binary bits, right? 0d, if you are writing some value, that value will be represented as decimal bits. So here generally in a microcontroller programming you will be using hexadecimal representation. So 1111 31 ones in hexadecimal, if you are represented it, if you are representing it will be 0x FFFF. So if you are writing IO direction 1 equal to 0x FFFF, you are configuring P1.16 to P1.31 pins. Those 16 pins you are configuring the direction as output. Similarly, we will take another example. This is not related with our experiment, it is only another example. So let us take your LPC2148. I am connecting two switches in P1.16 and P1.18. I am connecting LEDs from P1.19 to 31. So how will you configure the direction of this? P1.16 and P1.18, those two bits value in IO direction 1 register should be written with zeros. Why? Because these two pins should be configured with direction as input. Why? Because you are connecting an input device switch here, right? So wherever you are connecting an input device, that should be configured with 0. That means you are configuring it as input. And bit number 19 pins from 19 to 31 you are connecting LEDs. So these are bits from 19 to 31. All these pins, each pin is having 1-to-1 mapping, I have told here. So in this case, P1.19 to 31, that is bit number 19 to 31 of IO direction register should be configured with ones. So these pins you will be configuring as output. These two pins you will be configuring it as input. All the others are don't cares, right? So if you are writing hexadecimal representation, what will be that? 1111 means F is also F, F, F. The 4 F's are there. Here it is 1010. It is A. 1010 hexadecimal representation is A. Then FFF. So if you are writing IO direction 1 equal to 0x F F F A F F F, what does it mean? Except these two pins, that is P1 point except P1.16 and P1.18, all the other pins you are configuring it as output. This is how you are configuring the direction. Then in the third step, what you are going to do, now you have configured the direction. Second step is, the next step is you need to configure the data, right? Because now you have configured those pins as output. Next you need to configure that pin as, or you need to make the LED on. That means you need to write a data logic 1 into that pin. If you are writing 1, it will be generating VCC and the LED connected to that pin will be on, right? So you are going to configure the data as logic 1 or logic high. So here the same thing. How will you configure the direction? You are using a register known as IO direction X register, that is used for configure the direction. Here you are using another SFR known as IO set X register. Again X shows the port number. Here I should select IO set 1, right? So IO set register is used for setting the data as 1. Right, it is same as the other one. Here also 1-to-1 mapping is there. So if you are writing a value 1 in bit 0, what does it mean? P1.0 pin to P1.0th pin, you are writing a logic 1. So it will be generating a VCC in this pin, right? But in our case, I am connecting LEDs to P1.16 to 31. So if you are writing 1 to all these bits, what will happen? In all these pins 16 to 31 pins, all these pins will be generating VCC or 3.3 volt, or in other words you are setting all these pins as logic 1, right? So when you are writing 1, you will be setting the corresponding pin as logic 1 or LED will be on. So how will you make all the LEDs on? Bit number 16 to 31, in all these bits you need to write 1. So what will be the hexadecimal equivalent? The remaining bits also I am writing 1. It is a don't care, because you are having pins from P1.16 to 31 only in port 1. So what value should I write? IO set 1 equal to 0xFF. So wherever I am writing 1, those pins will be generating VCC, right? So when I am writing a logic 1 to a bit corresponding pin, it will generate VCC. In my case, all the pins I need to generate VCC. So all the 16 pins will be on. So I am writing IO set to 1 equal to 0x FFFF. So my LED, all the LED will be on. Next step, what should I do? I need to switch off all the LEDs, because I am going to write a program for LED blinking. How will you generate LED blinking? You need to make the LED on, then after some time you need to make the LED off. So now I have in the previous step I have made all the LEDs on. In this step I am going to make all the LEDs off. So for making it off, what should I do? Again I need to write a data as logic low. Previously I have written data as logic high, so LED will be on. Here I need to configure the data as logic 0 or logic low, so the LED will be off. So for writing or for setting the pins, you are using an SFR known as special function register known as IO set register. Similarly, for clearing a pin or for writing 0 to a pin, clearing means you are writing logic 0 to a pin. For that you are having another SFR known as IO clear register. Again X shows the port number. So I should take IO clear 1 register, IO clear 1. So similar to your IO set register, wherever you are writing 1, corresponding pin will be cleared. So you need to keep in mind here for writing 0 to a pin or for clearing a pin, also you are writing 1. For setting also you are writing 1. For clearing also you are writing 1. So if you are writing 1 to IO set register, that pin will be set. If you are writing 1 to IO clear register a particular bit, corresponding pin will be cleared. So for clearing also you are writing 1. You need to keep in mind. So for setting also you are writing 1. For clearing also you are writing 1. But the registers are different. If you are writing 1 in set register, that pin will be set. If you are writing 1 in clear register, that will be cleared. Right? So the same value you are writing IO. So from bit number 16 to 31, you need to write it as 1 because all these pins you need to make it as clear or 0. So the LED connected will be off. So you are writing IO clear 1 equal to 0x FFFF. That means all the pins, all the LEDs connected to all these pins will be cleared or switched off. Right? So these are the 4 steps required for controlling the GPIO peripheral or LED blinking program. But here there is one more thing you need to keep in mind. So generally LED blinking means what? You need to make the LED on, then after some time only you need to make the LED off. Because in your eyes, if you want to see something, it should stay in my eyes for at least half a second. Right? So in this program what you have done, you are making an LED, you are making the LED on in one statement or in one cycle. In the next cycle you are making the LED off. What will be the time taken for each cycle? How will you calculate that? You have configured it previously. You are configuring a peripheral known as GPIO. GPIO peripheral, I told all the peripherals are connected to VPB bus, and VPB clock I have configured as 15 megahertz. Right, P clock I have configured it as 15 megahertz, that is 1 by 4th of C clock. Right, in one of the steps here you have configured as by default VPB clock will be 1 by 4th of C clock. So my in default CCLK is 60 megahertz. So P clock will be 1 by 4th of 60, that is 15 megahertz. So your GPIO peripheral is operating on 15 megahertz frequency. So 15 megahertz frequency means 1 by 15 megahertz will be the time taken for one cycle to execute. 1 by 15 megahertz will be less than 1, it will be some point something millisecond. Right. So time taken for execution of one instruction cycle is point something millisecond. Right. Because you have configured PCLK as 15 megahertz. So what does it mean? Your LED will be on in point something millisecond. LED will be off in the next point something millisecond. Right. But I told you if you want to see something, that state should stay in my eyes for at least 500 millisecond. But now I am making the LED on in point something millisecond and making it off in point something millisecond. So it is very low. At least LED should be on for 500 millisecond, half a second. Then only I can see that. Right. So I need to make the LED on, wait for half a second. Right. Then only I need to make the LED off. Again I should wait for half a second. So how will you add this wait states in your program? You need to add some delay. So your actual program steps will be like this. First you are configuring the functionality, then you are configuring the direction, then you are switching on the LED. After switching on the LED, you need to add a delay. Right? Then you need to switch off the LED. Again you should add a delay. Why the second delay is required? Otherwise, after switching off, again it will go to switch on, and you will see that only it will be on always. So for LED blinking, what you should do, you need to write all these 6 steps, right? Out of that, the steps 3, 4, 5 and 6 should be inside a infinite loop. These 4 statements should be inside a infinite loop, because this program is for blinking in LED infinitely. That means you need to switch on the LED, give some delay, switch off the LED, again give some delay. So LED is on and off. Again you need to do this process. So these 4 steps should be in an infinite loop. Then only you will be getting the blinking effect. The other 2 steps are known as the configuration steps. Those 2 steps needs to be executed only once. Right. So once you have configured the functionality as GPIO, until you are reconfiguring it, it will be acting as GPIO itself. Similarly, you have once you have configured the direction as output, until you are reconfiguring it, it will be configured as output itself. So the first and second step, you need to, these are the configuration steps. These 2 steps you need to execute only once. Step number 3 to 6 you need to execute it infinitely, because so these are the actual program steps, these are the configuration steps. So this is how. So this delay you can be you can write it using any for loop or any loop statement. So in this program you will be writing only, you will be giving only some arbitrary delay. You are not generating actual 500 millisecond delay. Some delay you are generating. So you will be making the LED on, you will generate a delay. That means that LED will be on for that much time. Then you are making the LED off. Again you are giving the delay. So LED will be off for that much amount of time. So LED will be on, some delay will be given. LED will be off, again some delay will be given. Right? So it will ensure that both on and off state is staying in my eyes for at least half a second. Then only I will be able to see the blinking effect. If you are removing these 2 delays, I can see that LED is always on. That on and off state I will not be able to distinguish. That is why you are adding the delay. Right? So next slide, this is known as a register summary. So whatever peripheral you are configuring, there will be something known as register summary. From this you can identify what are the registers involved in configuring this peripheral. Right. So in configuring this peripheral, you need to configure pin select registers. Right. In addition to this, you need to configure IO set and IO clear registers. So register summary is used for showing what are the registers involved in configuration of a peripheral. So in addition to the pin select registers, you need to add IO set and IO clear register also. Here I have not mentioned that. That also you need to add. Right. So you can see what are the registers and what are the functionalities of each pins. So here I am using pin cell 2 register. So that functionality I have specified. If you are configuring pin number 2, bit number 2, you can configure it as GPIO or debug port. If you are configuring bit number 3, you can configure it as GPIO or trace port. Right. So these are the steps involved in blinking of an LED connected in GPIO port P1.16 to 31. Next, you are going to see how to write a program, actually write this program and execute it in a software known as Skill.